All right, good morning. This is the notes for day 121. And this is going to be a pretty short video. I don't have many notes today because most of it is going to be you working on a practice sheet. So my notes are more with tan inverse and derivative of cosine inverse of x. Okay, so let's try the warm-up. It's been a couple days since we did these trig inverse derivatives and integrals, so let's review a little bit. Let's say I want the derivative of tan inverse of 2x to the 6th. What would you do? Okay, now remember the derivative of tan inverse of stuff is 1 over 1 plus the stuff, so 2x to the 6th squared, times the derivative of the stuff, which would be 12x to the 5th. So it'd be 12x to the 5th all over 1 plus be 4x to the 12th. There's nothing more you could do. The derivatives aren't too bad. You just got to remember to use chain rule. Number 2. Let's take the integral from negative radical 3 over 3 to 0 of 3 over 1 plus 64x squared dx. Now just those bounds alone should give you a clue that it has to do with trig inverse, because think of radical 3 over 3. When do you see that? When you're evaluating triangles. So you have to think, does it sine inverse or tan inverse? And it's tan inverse because there's no radical. There's a plus on the bottom. So we're going to bring this 3 out front. Call this 3 times the integral from negative radical 3 to 0 of 1 over 1 plus 64x squared dx. Now remember, with these, I want this final piece on the bottom to be u squared. So we're going to do a u sub. This is where we do let u squared equal 64x squared. So what would u be? Take the square root, just 8x. That's where you get your new bounds from. So if you plug 0 into 8x, you still get 0, so the upper bound's not going to change. But if I plug radical 3 over 3 in, we're going to get, oops, and I just noticed that it's supposed to be radical 3 over 8. So don't be mad, just make that 3 into an 8 over here. So radical 3 over 8, make it nicer for us. So if I plug in negative radical 3 over 8 into this, what's it going to end up being? Just negative radical 3, because the 8's will cancel. Okay, so then du over dx, what's that going to be? Just 8. And I just want to solve for dx. So du over 8 equals dx. Okay, so what's going to end up being out front? We're going to have 3/8 out front times the integral from negative radical 3 to 0 of 1 over 1 plus u squared, 64x squared is u squared, du. What's this become? That's the derivative of our tangent formula, so the integral will be 3/8 times tan inverse of u times the integral from negative radical 3 to 0. You have to be able to evaluate that by hand. So leave the 3/8 out front, and then we're going to have tan inverse of 0 minus tan inverse of negative radical 3. So tan inverse, remember, what do you shade out? The left-hand side. And what's tan inverse of 0 going to equal? Well, again, you got to think of it's a quadrantal. This is the point 1, 0. So tangent's y over x. So this would be 0 over 1, so it's this spot. So tan inverse of 0 is just the angle 0. Minus, do the same with this. Switch to the left-hand side. Tan inverse is negative, so we're down in this quadrant. Tangent opposite over adjacent, so opposite's negative radical 3, adjacent's 1, hypotenuse is 2. This angle would be 60, which is pi over 3, but since it's in the fourth quadrant, we don't say pi over 3, we say it's got to be negative pi over 3, remember, because of the restrictions. So this is just 3/8 times pi over 3. 3's are going to cancel. Pi over 8 is your final answer. Good? Hope so. Okay, one more before we do my new stuff. Here's number 3. Let's do the integral of 9 over 4x squared plus 121 dx. The 1. Okay, now these are the ones that start getting a little trickier because you don't necessarily see the inverse tan in that. But again, if you did regular u sub, if you made u equal this bottom piece, you'd have an x in your derivative, and there's no x in the leftovers. So you do need to make this look more like what we're used to. For one thing, with these inverse tangents, the x is the second term. So rewrite this as 121 plus 4x squared dx. What am I going to do with the 9? 9's going to get pulled out front, so that's fine. What else needs to happen? We need this to be a 1 if I'm going to use one of those inverse formulas. So I factor out a 121 on the bottom. Now it's 1 plus 4x squared over 121 dx. I can pull this 121 out front as well to make this 9 over 121 times the integral of 1 over 1 plus 4x squared over 121 dx. Okay, now I'm finally ready for some u sub. What do I want to do? We want to let u squared equal that bottom right. So 4x squared over 121. Take the square root. That means u is going to equal what? 2x over 11. I don't have to worry about new bounds because there are no bounds. But du over dx, the derivative of this would be, it's just 2/11 x, so it becomes 2/11. And the leftover piece is just dx, so what's dx going to equal? 11/2 du. Okay, so when all is said and done out front, we're going to have 11/2 times 9 over 121 times the integral of 1 over 1 plus u squared du. The 11 and the 121 can cancel. That's gone. That becomes 11. So I have 9 over 22. What's this turn into? Tan inverse of u. Don't forget your plus c because we don't have bounds. And just go back and plug in what u actually is. It's going to be 9/22 tan inverse of 2/11 x plus c. All right, so that's where we were at. And the only major trig function we haven't talked about its inverse is cosine inverse. So that's what my one page of notes is going to be. The derivative of cosine inverse of x. So first off, the derivative of cosine inverse of x is just -1 over radical 1 minus x squared. Now you notice that's really similar to the sine inverse equation. I think the only difference is that negative up there. You'll see why that's there in a second. And the derivative of cosine inverse of u is negative 1 over radical 1 minus u squared times the derivative of u. Good old chain rule. Now, just so you have them all written on one page, let's compare this. What's the derivative, again, of sine inverse of x? It's 1 over radical 1 minus x squared. So almost the same as this one without a negative on top. And we just did a bunch of the derivative of tan inverse of x. That's 1 over 1 plus x squared. So tan inverse looks a little bit different. It makes sense that sine and cosine are pretty similar. I'm not even going to talk about the integrals involving negative inverse cosine, because if you had a negative in an integral, what would you do with it? Yeah, you'd just pull it out front, and then you'd have inverse sine. So we're not really going to do those. Okay, let's see why that negative's there. So your original function is y equals cosine of x. So my inverse function, we switch x and y, x equals cosine of y. Remember how I came up with all these formulas for the rest of them? I've used this to derive implicitly. So derivative of x would be 1. Derivative of cosine is negative sine, there's the negative, of y, dy dx. And if I want to solve for dy dx, we would have dy dx equals 1 over negative sine of y, or negative 1 over sine of y. Again, there you can see why the negative came up. And just like the other ones, I don't want my answer in terms of y, I want my answer in terms of x. If I have cosine inverse of x, that's how I want my derivative to be in terms of. So we use the formula sine squared y plus cosine squared y equals 1. Sing the chorus once. Solve for sine squared of y. You would have sine squared of y equals 1 minus cosine squared of y. We need to take the square root to get what sine of y is. So I can plug that in. It's negative 1 over the square root of 1 minus cosine squared of y. But we said that cosine of y was x, so cosine squared of y gives you negative 1 over radical 1 minus x squared. Okay, so that's why the negative's there, all because the derivative of cosine is negative sine. When we were doing this with sine, it's the exact same derivation, except the derivative of sine was positive cosine. I don't think we need many examples. Let's just do 2. If I say y equals cosine inverse of 2x, and I want you to find the derivative, what would you do? Y prime equals negative 1 over the square root of 1 minus the stuff, so 2x squared, times the derivative of stuff, which is 2. So we'd have negative 2 over the square root of 1 minus 4x squared. Okay, and one more. Let's say I started with y equals cosine inverse of x squared. What would y prime be? We'd have to start with negative 1 over the square root of 1 minus the stuff, x squared squared, times the derivative of that stuff again, which is 2x. Just gives you negative 2x over radical 1 minus x to the 4th. Okay, so definitely, if you're going to see this show up on the AP, it's probably going to be sine inverse or tan inverse. So focus on those. Don't worry too much about cosine, but I just wanted to talk about it because it'd be weird not to. Okay, 2 final questions. This is kind of some random review, but you'll see why I'm doing it once you do the next problem set. What if I asked you to evaluate tangent of sine inverse of -1/2? Do you remember how to do that? So it's a pre-calc question. You have to start in this piece first. So I would draw a triangle. Since it's sine inverse, so we shade out left-hand side. And it's negative, so I'm going to be in the 4th quadrant. Opposite is -1. Hypotenuse is 2. So what's the missing side? Radical 3. So do I know the angle? Sure, it's 30, but I don't really care about that, because all I care about is that this whole answer was equal to some angle. It's supposed to be a theta. And now I want the tangent of whatever that angle is, which I would just use this picture anyway. We would say opposite over adjacent. Opposite's -1, adjacent's radical 3. That's my answer. So it's kind of a composition. Draw a picture for the inside, and then evaluate the trig function that's on the outside. Okay, last one. What about if I asked for cosine of sine inverse of radical 2/2 minus cosine inverse of radical 3/2? Anyone remember what you would do with one like that? Well, we got to draw a picture for each of these. So sine inverse, we know we get rid of the left side. Cosine inverse, what do I get rid of? The bottom. So sine inverse of a positive radical 2/2 is going to be in which quadrant? Quadrant 1. And remember, I don't want to write this as opposite radical 2, hypotenuse 2. I want to think of this as 1 over radical 2, so it's a special triangle. Opposite's 1, hypotenuse is radical 2. Missing side would also be 1, so this would be 45. And then cosine inverse of radical 3/2, adjacent's radical 3, hypotenuse is 2, missing side's 1. That's a 30-degree angle. But really, I'm going to think of this as triangle A, and this as triangle B. Because what I'm really looking for is the cosine of whatever angle A is minus whatever angle B is. And that should definitely ring a bell. I want cosine of A minus B. What do I use? Sine, cosine, cosine, sine, cosine, cosine, sine, sine. This is cosine, cosine, sine, sine. Put your A's and B's in. If it's a negative inside the cosine, if it's a minus sign, what goes here? Remember the sign stays the same, cosine it changes, so that's going to be a plus. So now use your triangles. What's cosine of A? 1 over radical 2, or radical 2/2. What's cosine of B? Adjacent over hypotenuse, radical 3/2. Plus sine of A. 1 over radical 2 again, or radical 2/2, and sine of B. Opposite over hypotenuse, 1/2. So my answer is going to be radical 6/4 plus radical 2/4. Radical 6 plus radical 2, we can't combine those anymore, all over 4. All right. So I did those because in the next problem set that you do, so you can now do problem set 114, you'll have some questions like that. Okay. So what I want you to do for the rest of the day, because that was kind of a half period lesson, was go to your work packet, find the thing that says classwork day 122, practice with inverse trig, and I want you to do this worksheet. So you should all have this. If for some reason you don't, do it on a separate sheet of paper, but you should definitely have it in that homework problem set packet I gave you. The front is all derivatives. The back is all integrals. This is one of those things that if we were in class, we'd be spending a day in class working in groups, and I'd have you turn it in at the end of class. So I want you to work on this, turn it into me, and check your answers. These are the answers you should be getting. So maybe take a picture of this screen right now so you can check as you go. But I do want you to send me back pictures of your answers. So complete this today and check your answers and then send me back pictures. I'm going to count this as a 10-point homework grade again. So it's another way to boost your homework grade if it isn't as high as it should be. All right, let me know if you got any questions. Good luck.